My name is Nicolai, and I'm here to talk about JUnit 5. Before I start with that, if anybody of you have ever seen me talking about this topic before, now's a great time to leave. Because the talk will bring you through all of JUnit 5, and so it's very similar to what I've talked about before. There are a few new details in there, but other than that, you would see a lot of things you already saw before, and I don't want to bore you. So, quick question. Who has been using JUnit 4 ever? Great. This month? This week? Today? Nobody. Oh, yeah, one guy. Yay. Great. Cool, because now we're going to talk about JUnit 5, of course, but I'm going to need your help soon. So JUnit 5 is work in progress. It's been under work for almost 2 years now, and what I'm going to present you today is a milestone, one of several milestone releases. It's the newest one. It's out in 1st of April, but it's not an April's Fool joke, I've been told. And GA release, we can hope for one in September. Nobody knows whether it will make September, but we hope it will. Which means now is still a great time to give feedback. And if you want to do that, there are several places. There's a GitHub repository, of course, where you can create an issue after you've searched for the ones that are already there, about pretty much everything that you feel should be included in JUnit 5. Or if I show you something today that you think goes the wrong way, it's a great place to discuss with the team. The user guide is pretty awesome. They're active on Twitter. I blog about it on my blog. And if you want to see the slides, they're already online now. You go to slides.codefx.org, and you'll see them on the right side. It's the blue one. That said, I'm not a member of the team. I just talk about JUnit 5 because I think it's an awesome project, but I don't speak for the team. Okay, these are the topics I want to talk to you about today. I want to talk about some basics that will show you how to use JUnit 5, about two interesting things, dynamic and parameterized tests. Then we're going to discuss the extension model, how people can extend JUnit 5. In the end, we'll come to the architecture. And then if we have time, I'll walk you through how to set it up. But that's a little bit optional. You can look that up online. So what I'm going to do now is I'm going to show you valid JUnit 5 tests. And they will seem very familiar, but they're not quite the same as JUnit 4. And you to tell me what the difference is. So what's the difference here? Why is that not a JUnit 4 test, but a JUnit 5 test? Sorry? Yeah, exactly, package scope. So the public keywords, I didn't just drop them to make the code fit on the slides. You don't need that anymore, which I think is a great little detail that was improved. What's new here? Yeah, new-ish, right? So we had before class and before, now it's before each and before all, but they do the same. The lifecycle methods work exactly the same as before. The annotations just changed their names a little bit. I like these better because they're less technical. What's new here? Exactly, it was ignore. I thought it was ignored. I never used that, or I didn't use it very often, so I thought it was ignored, but it was ignore. Now it's disabled, so that's just a small difference. Oh, that's not so great. Ah, there we go. What's new here? So who thinks this is part of the public API? Who think it should be? A couple, great. So this is not, unfortunately, part of the official JUnit 5 API, but we can make it so. We can extend JUnit 5 in a way that it ends up looking like this. This is awesome because it's seamless. It looks exactly the same way that the native JUnit 5 things look. And we'll see that later when we talk about the extension model. A couple of small things changed around assertions. I think most people use maybe Hemcrest or SRJ or Google Truth as an assertion framework, so I don't see a lot of reason to go through all the small changes. This is one of the more interesting ones, particularly because you can use it with these other assertion libraries as well. So what's new here? Yeah, so the assert all is new, and it will check everything. That's interesting, because before you have the problem if you have a couple of properties and you want to make sure each one is checked. All of these assertion libraries give you a way to write a custom checker just for that class, which nobody ever does. Usually you just have these 3 asserts there, and when the first one fails, you always ask, like, what would have been the other 2 ones? Now you know. You can do this. Use lambda expressions to defer the execution until assert all actually executes all of them one by one, and then tells you that in this case, all 3 of them are false, which looks like this. So it now tells you that what was expected and what it got on all 3 of those. that's, I think, great improvement. What's new here? That's so easy, come on. Nested, yeah. Did anybody ever do this before? Not with nested, of course, the notation is new, but did anybody ever organize tests in nested classes? Okay, in JUnit 4, there was a runner for that. I think it was even called nested, I'm not sure anymore. I do that occasionally. There's a great example coming up for how you could do this, but you can already see it here. The idea is that I have a class that tests some counter, apparently, and I can have lifecycle methods here, and then I can have an inner class, which is the tests are also run. I can have new lifecycle methods here, and the interesting part is that they are executed outside in. So I can slowly build the state that I want to test. I can have the counter assigned here, and then this before each method, I would maybe set it to a value, and then here I would set it to a much greater value than I have my test there. So you can organize them in inner classes. Okay, this display name is new here. So if you're going to go through all the work to basically repeat part of your name in there, then you can make your names really expressive. Every tool that looks onto JUnit 5 from the outside will think this is what the test was called. When you combine nested and display name, you have to put in a lot of effort. Well, not a lot maybe, but you have to put in some effort, but you can get really great results. So if I want to use display name to show a nice name together with nested, you can do something like this. This is the output from IntelliJ. This is an example that comes from the user guide. And you can see here that the class used to be called a stack apparently, and then there was an inner class called when new, and then you can see a stack when new after pushing an element, it is no longer empty. If you're going to go through the effort to write your tests like this, then you will be rewarded. If this test fails, you know what went wrong. There's not even a reason to look at the code anymore. You know what should have happened. What's new here? Yeah, the parameter is new. So I called in my server to make perfectly obvious that this is a class that I implemented. So this, of course, raises the question, how would JUnit know where it comes from? And we'll see that later, but it's a new thing, a new concept to have parameters in test methods. And that was already the basics. You can see that a lot of the knowledge that you have from JUnit 4 works very well in JUnit 5. On the surface, writing simple tests, you already know 90% of what there is to know. You used to know 90%, now you know 100%. So lifecycle methods, the tests and before and after work exactly as before, just have different names. A lot of small details were improved. And nested and display name make a nice couple if you want to use that. And we've seen parameter injection. And that's all nice, but the talk is called, or subtitle is called Next Generation Testing. And this is hardly next generation testing, right? So I still owe you a little bit. That was the basics. Do you have any questions about the basics? Anything that was not clear? Now would be a good time to ask. You can, of course, ask later as well, but if you have questions about what we just talked about, now would be a great time to ask that. Will JUnit support old annotations? Will JUnit support old annotations? The short answer is no. The long answer is it will still work, and we'll come to that when we talk about the architecture. How do you test for exceptions? The old JUnit 4 used to have the expected and the timeout as parameters behind the test annotation. The team didn't like that decision in retrospect because it kind of like overloaded the test annotation. Also, it was not a nice way to do it, right? Because you never knew which exact method threw the exception. So you can have a test pass for the wrong reason. This is assertion now. You can have assert throws, and then you give a lambda expression, and then assert throws executes that lambda expression, which is likely the method call you want to test. And then you get the exception back, and then you can assert the exception. And the same is true for assert timeout. You can say assert timeout, do this thing, and then assert timeout does this thing and measures how long it takes, and either preemptively aborts the execution with an executor service in the future, or it measures the time and then says then it didn't pass. Yes? Will before method work without static? So before each and before all and after all are run at the very beginning and the very end of that test class. And they had to be static in the past. I think actually in milestone 4, they don't have to be anymore. Or maybe that's a change that will only show up in milestone 5, but the code is already merged. So the JUnit 5 snapshots, you already don't have to do that anymore. Let me go into dynamic test. This is the short version of this chapter. I will disappoint you in the end and show you where to read up the rest, but it's still an interesting concept that JUnit 5 brings to the table. So before JUnit 5, in JUnit 3 and 4, and even what I just showed you, you had to define your tests at compile time, right? So you wrote a test method, and that was a test then. So why would that be a bad thing? But as a default, it's a great default. It works fine. But there are cases where it doesn't work anymore. For example, if you want to create tests for a couple of parameters, ideally you want to have one test case per parameter. But at compile time, you might not know whether you have 5 or 10 parameters. Or you might actually know that it's 5 parameters, but they're somewhere in a list. So the compiler can't help you to tell you like you need to implement 5 methods. So if you want to move to a place where you have one method becoming 5 tests, you need to have a possibility, or JUnit needs to have a possibility to create and register tests at runtime. The same is true, for example, if you want to have non-source files, maybe some simple domain-specific language that was developed for your product where a Q&A team could write tests, or if you want to use lambdas. Some people want to have lambdas to create tests because it's the new shiny thing. Anyway, in all of these cases, you would have to create tests at runtime. And this is what dynamic tests allow. So dynamic tests are a pretty simple concept, actually. So a test is wrapped into something which is called a dynamic test. It's a class. This class has just a name, the name of the test. Also, it's at 2 fields. One of the fields is the name of the test, and the other field is something like a runnable that can execute. And then you can annotate your methods instead of with test. You annotate a method with test factory, and it just creates a couple of dynamic tests. I used to do a long chapter on how you can use that, but for the most important use case, parameterized test is actually a better approach. But it's still interesting to look at this because of the effects. Because these are fully fledged tests. If you do this, then every tool that looks onto these tests will see them as separate tests, and the IDE will show them as like that. For example, IDEs or build tools. And they're integrated into the full life cycle. This is not specifically true for dynamic tests, but for the other ones I'm going to show you. And if you want to know more about dynamic tests, there's a link down there that I can recommend you read. Because that was our dynamic test. Let's now do parameterized tests, which is a pain point in JUnit 4, and where the team worked a lot to make progress in JUnit 5, and which also makes use of this concept, of this idea that at runtime, JUnit will register tests that were not present in the source code. There are different ways to do parameterized tests. There are in JUnit 4, there are theories, for example, which has a special way of working, and there are other ways. The most dominant use case is this one. I have one test method, and I know I want to test it with 5 different inputs. And I want to run the test method, of course, once per input. And for this specific use case, JUnit 5 has native support. We'll see later which other options might exist. I will say something about that. So this is pretty easy, actually. You create the test method, and you don't say test, you say parameterized test. And then you need to define where the values are coming from. And here use the value source and say, look, the strings are hello and JUnit. And then it happens what seems natural at this point. The method gets called twice, once with hello, once with JUnit. And if I execute this with the current version of IntelliJ, I get this output. So I get test with value source, which is a method. It shows up as a node, which is in this graph. It shows not a leaf. It has nodes below it. And these nodes are 1 and 2, because I ran it twice, with the values hello and JUnit. And if I don't like these names, I can do some stuff and define the names I want to use there. But this is the basic case, which I think is really simple to use. But value source might not be the best or the only way to do that. So there are a couple of different sources. This is where you can really use, you can imagine what kinds of inputs you have and how you can put them in there, what's the best one. So value source is the one I showed you. It's really simple, but it only works for single arguments. And you need to have something else if you have like a couple of arguments that you want to pass in. Another source is Enum Source, where you can just say, take this enum, and then every value of that enum will be put into that method once. You have a method source. Method source says, execute that method over there, which will generate a couple of values, and use those as arguments for this method. And maybe the most interesting ones are the two at the bottom, CSV source and CSV file source. With CSV source, you can kind of write something like, which looks like a comma-separated value string, and JUnit will do this, like split it at commas and generate values out of that and pass it on. We'll look at that soon. And you can do the same by loading from files. And the interesting thing is you can mix and match this. So for example, you have a test case where all the good cases are in some CSV file that someone created for you. And then somebody comes up with, I have a problem there, I found this other use case which we have to test. You can just add the value source then, for example, or whatever other this seems applicable, or maybe you have two different files or whatever. So you can use many of these sources at the same time. So, for example, to do this with an enum, you do this. You say enum source, and this is the enum, and then gets passed in there. You can also say I only want specific enums, specific values, and you have to name them and give them the string representation here, and then it gets only called twice for nanoseconds and microseconds. The method source, as I said, is also pretty easy. You just say this is the name of the method. I think this is going to change in the next milestone. I think in the source code it's already not names anymore, but a different name. Anyway, so you say this is the name of the method I want to call. So then JUnit calls this method, and then this one returns a stream of strings, and then the strings get passed in there one by one. Now, what do I do if I have more than one argument? This is where this class, this interface comes in. It's called arguments. And the idea is that you have one arguments instance for each run you want to have. So if I want to have one run with hello and 5, and one run with JUnit 5 and 7, like this, then I create two arguments instances. So this way I can create values and then pass them in one by one. This is where things get interesting, because this might be a very succinct way to define the data you want to place in there. You can use the CSV source, and then you just write out the things. So you can see that there's one string for each invocation that I want to have. In this case, I would have 1, 2, 3 invocations of this method, and this string would be 0, 0, and 0, and then this string would be 0, 1, and the 1, and then 1, 1, and 1.4. So each of these strings provides all the arguments for one execution, and then JUnit splits them and does things, because this is interesting, but this is just strings and doubles. This seems simple. How do they get converted? So as I said, for zeros and other numerical values, it's obvious that JUnit can just do that, right? And it does that for a couple of simple data types like primitives, for all enums, and for the things that are in java.time, like duration and instance. Everything more complex is, of course, up to you to provide. How would JUnit know to create, I don't know, in this case, a point here? And you can do that. You have to implement this thing. You have to implement a converter, which is a very simple thing. You just pass, and basically it just receives strings and churns out the data you want to use here. Sorry, the type you want to use here. So in this case, you can actually, the critical difference is here. I don't accept the point as a string anymore. I want to have it as a point. So when you want to run tests with something which like value-based types or things that look like value types, which are like point, very easily representable as a string, then this works fine. Of course, you have a complex business model. This is unlikely to work like this. But then you've seen the method source that you can use to generate actual objects. And all the same things that I just told you about CSV files, CSV source, also applies to the CSV file source. We just point it to a file, and then the same thing apply. Like this file has to be comma-separated list, so you have one line per call, and then you have within those arguments, JUnit will split them, will convert them, and will ask the converters you apply here in case that it can use the string to create whatever you have here. And the interesting part is you can generate your own sources. So if you if you have some specific feature in your maybe in your library or in your business logic that would make it interesting to create a specific way to create objects for your tests, then you can just do that. You can just implement this arguments provider interface, which is again very simple. You get some parameter here that we're not going to look at, but you just say like, look, give me a stream of arguments back. So you just do that. In this case, I create 3 random integers between 1 and 10, and just return them here this way. So it's the first thing I do. I just implement this interface, and I'm done. And the second thing is I apply it here with argument source, giving it the class that I just implemented. And now I can with these 2 simple steps, I implemented my own source for tests. So now I can parameterize my methods with these concrete instances. Great, so as a summary about parameterized tests, we have seen that it's really easy to declare a test method. To declare a parameterized test method with an annotation of the same name. And then on top of that, you have to apply sources. You have a couple for your choosing, which I think these one are the most interesting ones, but you can also create them yourselves. And this is the interesting part. Interesting sentence maybe on this most interesting sentence on the slide. So this was one variant of parameterized tests. If you think about something like theories, which I think have a very small use case, but they do have a use case which is very valuable, then doing theories with this would be a little bit tougher. So the extension model would allow you to you or somebody else who works on a testing library to provide other ways to parameterize tests, which don't look like this at all. They wouldn't use the same annotations. They wouldn't use the same mechanics. You could come up with whatever you want, basically, and then via the extension model, make that work within JUnit. We're going to look at the extension model next, but not how to create parameterized tests, because that's a little more complicated. But again, it's really nice, but it's hardly next generation testing. It's a nice thing that JUnit 5 finally has good support for that. Do you have questions about parameterized tests? So the question is how does CSV source handle system delimiters? It uses a library whose name I have forgotten, uni something parsers, and you can pass in some delimiters and other things in there. So I guess those things are accounted for, but I don't know about the details. Other questions? That's good. So the question was about JSON. There is no JSON source. That would be a great extension to write. Or you just create an issue. Since they did include CSV, JSON is not impossible, I think. Okay, let's plow on then. Let's look at extensions. Let's look at how we can make JUnit fit our personal use case better. So JUnit 5 has a core concept, which is prefer extension points over features. Many of the features that I've showed you so far are actually implemented via extension points, which means that JUnit 5 uses an API to implement that feature that is also available to you, which means that these extension APIs already, I wouldn't say battle tested, but let's say skirmish tested. So it has already some use cases. So JUnit 5 actually has literal extension points. And what is an extension point? These are extension points. So we're not going to go through all of them, but you can see some things here. Like you can see, for example, the lifecycle methods before all and before each. There seem to be some callback thing. Parameter resolution corresponds to the fact that methods can have parameters. Then you have exception handling here, for example, which makes sense because, of course, a method can throw an exception. So maybe you want to interact with that. You see, these are different extension points. In the end, an extension point is just an interface. And most of these interfaces are really simple. So you have one interface for each extension point. And usually, JUnit captures all context, so all the interesting context that is currently going on at that point in the test execution, gathers that into an instance of test extension content or container extension content, but you get one of these extension context and you get them passed into your method. When you remember back at when I talked about creating your own sources, there was the brackets with had 3 dots in there. I said I wasn't going to talk about that argument there. It was one of these. So JUnit would capture the context, pass it into your extension, and then you just do whatever you think works best for you for that extension. And of course, you will implement several extension points usually to interact with several. So have your extension interact at several points in the test lifecycle with JUnit. So let's do some simple extensions to see how this works. So the first thing is you want to benchmark our tests. And if you write that like this, we say for each test method, we want to write the elapsed time to the console. This is more like a business language, like regular language. We can write more technical. We can say before the test execution, store the launch time. After test execution, print the elapsed time. And this is almost as precise as the code. So you will see that before and after test execution, there are extension points before test execution callback and after test execution callback. And we simply implement both of them, declare a field here, and then override the 2 methods that belong to the interfaces. And you do exactly what we just described. Before the test execution, I take the current time millis and assign it to system. I'm a fan of static imports, so this would be a static import. After test execution, you just do current time millis, subtract the launch time, and then you format the thing, and then you print it out. So this would be a very simple extension that just runs before and after each test execution, stores the time in between. So remember, disabled on Friday. Let's see how that worked. There is a test execution condition. That's an extension point. That interface has one method. The method is evaluate, and it returns an evaluation result. So the idea is you return an enabled result when the test is supposed to be enabled and a disabled result when it's supposed to be disabled. These are the corresponding static factory methods on that class. And here we also get this context, but we don't need it. Like before, we're just going to ignore it because all we do, we check whether it's Friday. And however you want to implement that, you check whether it's Friday, and if yes, you just disable the test. And there you go. There you have the extension that we talked about. Last one, I promise. Parameter injection. How does my server get here? This used to be the most complicated extension point. Now the way to customize parameterized tests is considerably more complicated than that, but it tells you about generally how simple these extension points are, because this is most complicated because it actually has 2 methods. So what you do here, first JUnit is going to ask your extension, look, this is the context of the invocation, specifically this is the parameter I found. Are you in charge? Do you support this one? Yes or no? If you say yes, then you will be asked later to resolve the parameter. If you say no, then you won't. If several extensions say yes, then JUnit quits and says, several extensions said they were going to support this. I don't know which one to call. Fix this. So in this case, I resolve the parameter here and just return a new my server. This example works based on the idea that I have this class and I know I want to create this class. But you can think about other extensions. Maybe, for example, you have an extension that mocks objects. Of course, mocking is possible for all kind of objects, right? For all types. So the mocking library would always say yes here, and then would sometimes lead to conflicts. So it would be a different way to do that. Different way would be you annotate the parameter. The extension would only be activated, would only say I support this type or this parameter if the parameter is annotated with, for example, at mock. You can ask the parameter context and say, what are the annotations, or you can even ask what are the annotations on the class, or you can, from this context, you can explore via reflection the whole surrounding of the test. And you can come up with whatever kind of rule you want to decide here whether you support a specific a parameter, and you can do the same stuff here to create that parameter. So how do we apply extensions? So far, we've just created extensions. How does JUnit 5 know about them? This mechanism is really simple. You just apply this annotation extend with something, whatever your class is, and then you apply it to either a test class or a test method in there. And that's very nice. It works, but it's really technical. It doesn't look so beautiful. Remember that at disabled on Friday, that looked much better than this. So this is the way that works. Now we're going to look at the step that makes it more seamless. This is my experiment to see how often I can write annotation on the same slide. Who knows about meta annotations? Okay, meta annotations are actually nothing complicated. It's just something a little bit unusual. If you ever written your own annotation, you might have added another annotation on top of it, like retention policy or target. That was a meta annotation. A meta annotation is nothing else but an annotation on an annotation. This is a Java feature. What JUnit 5 does, it is aware of this feature and looks for meta annotations. So whenever JUnit looks, for example, on a method and it sees 3 annotations, it doesn't stop there. It then looks for more annotations until it explored the whole tree of meta annotations, and then it acts as if all of them were present immediately on the test method. So this means you can apply annotations without having them directly present. You can make it once removed or twice removed by putting them on other annotations. So we can create our own and use them within JUnit. So the one above is the simplest one. I did not put in the retention policy and the target here, but this is the essence. You create a new, this is the way to create an annotation. You create a new disabled on Friday annotation and just extend it with your own extension. And you can do the same thing, for example, for integration tests. Let's say for integration tests, you want to say integration test is, of course, a test. I want to tag it. You can use tags to filter test, which we're not going to look at here. And then I extend it with benchmark extension because you always want to know how long integration tests run, and because I want to most likely test my parameter, I put this resolver in here as well. And then I created a new annotation integration test. And now when a test method like this occurs, then JUnit 5 comes along, picks integration tests, and resolves all these. Sees disabled on Friday and restores all these, and then explores all these. So in the end, it's like as if test login had these 5 annotations on there, which means JUnit 5 knows it's a test. It knows it has 1, 2, 3 extensions, and it's tagged. So this is the way to integrate our own extensions into JUnit. So the summary of the extension model, it's very flexible. You have a lot of different ways to interact with JUnit. It's not complete yet. There are things you can't do yet. For example, there's no extension point to push the execution of a test onto different threads. So if you've ever tested UI, then you know that you have to do it in a swing event dispatch thread or in the JavaFX application thread. So for JUnit 4, they used to exist rules which would basically take the test that you want to execute and execute it in that thread. For that kind of extension that interacts with threading, there is no support yet. I hope there will be before the GA release, or otherwise at any time after that. Extensions seem to compose well. It's always hard to tell until there's a gigantic ecosystem of, like with JUnit 4, like with rules. It will take a while to find out whether they really interact perfectly or whether they do stomp on each other's feet, but they were designed in a way that would make it at least less liable, reduce the chance of that happening. And because of the meta annotations, it's really nice to customize those. So again, where's the next generation of testing? Again, we're still talking about JUnit 5 being great to use in your project, but that doesn't answer the question of what that has to do with the rest of the JVM. Second to last point, architecture. Oh, before I go to that though, questions about extensions? Yes? So is it possible to set the sequence of tests? This goes into the direction of like what TestNG does, I guess. The TestNG has one test instance, and then you can define it in an order in which the test methods are executed. For example, so you can slowly, let's say, I log into the web service, then fill the card, then check out the card. This is what, in JUnit 5, these are called scenario tests, and this is what the current milestone will hopefully eventually deliver. If not, the team thought about maybe doing first a 5.0 release and then do scenario tests after. But there is no support yet because they want not intermingle this other way of doing tests with the more normal unit tests. So they want to make sure that there's a separate API for that looks differently. Like says most likely scenario test and then explicitly links to how tests and which order tests are executed. And I hope that then there will also be an extension point for that. But that is not the case now. Yes? There would be the question whether there would be new test suite API instead of the existing one. Yes, JUnit 5 is a total rewrite, and while concepts that JUnit 4 used might still end up in JUnit 5, I would not think that test suite is one of them. And even if it would end up, it would just be the concept, not the same code. More questions? Okay, then now architecture. If you wonder now, like, why would I care about JUnit 5's architecture? Wait, in the end, I guess you will care. So if we talk about JUnit 4, then the word architecture, if you talk at an artifact level, then it hardly deserves the term architecture, because it's really just JUnit 4 and then there's a little Hemcrest on the side. But other than that, everything is in one jar. So when you write tests, you use that jar. When you write an extension, you use that jar. When you are a tool and you want to execute tests, you use that jar. And the whole mechanics of executing and finding tests, or the other way around, they're all in there as well. So there's no separation of concerns at all. And this is not just an academic complaint, it actually has consequences. Because the tools that we use, IDEs particularly, give us a lot of nice features, but the API was often not powerful enough. So what do you do when you use a library and it has the thing you need, but it doesn't expose it? Somebody laughs. Reflection, right? So sure, that's what happened. Tools started to use reflection to go into JUnit 4 and take out the values they needed. And this was a problem because it bound tools to implementation details. And this made maintenance very hard. Imagining working on a project where you can't change some field names because then some downstream tool will break. This is not a great way to maintain a library. And this was apart from this other one was the extension model in JUnit 4, which was not that great. It worked fine, but was not, could be improved. That was one big reason. And the architecture was the second big reason why JUnit 5 is a rewrite and it's not just JUnit 4.13. So JUnit 4 was kind of like ended up in a dead end. And Johannes Link, who was one of the initiators of the new project, once put it like this: the success of JUnit as a platform where everybody writes tests against and other extensions and even other test frameworks integrate with, that success prevents the development of JUnit as a tool that we just want to use to write tests. And they want to develop a JUnit 5 that doesn't have that weakness. So the idea was to separate concerns, to have an API to write tests against, and then you have an API on the bottom and you have an API for tools to run tests. That makes sense to separate those. And then in the middle, like kind of sandwiched, you have a mechanism that gets told do something and then looks at the tests and builds the whole thing. Or what I just told you, like look at what is annotated with a test and check the extensions and all of that. This was the original plan. And then when they looked at the second point a little longer, they realized that there's another split they can do. So first and third are the same. You have an API to write tests against. At the bottom, you have an API for tools to run tests. But in the middle, another layer of abstraction was introduced. So for each specific kind of test you want to write, you get one engine. And then something orchestrates engines. And in between that, you, of course, need an API. This is a critical difference in thinking what JUnit 5 does, because that splits JUnit 5 in a lot of submodules and subprojects. Like, I don't know the number at the moment, but it could be somewhere at least a dozen, maybe more, towards 20 jars that make up JUnit 5. And this also means that there are a couple of new names. One of the three subprojects is called JUnit Jupyter. Whatever I told you about so far, the API, the extension model, all of that is part of Jupyter. So if I would have been precise from the beginning, I would have always said this is JUnit Jupyter stuff. Then you have JUnit Vintage, which operates on JUnit 4, but integrates JUnit 4 into this mechanism. And then you have the platform, which is a totally new concept. The platform is meant as an integration point for tools, specifically IDEs. So they would never again have to talk directly to these artifacts up here. They will always only go to the platform and tell it, here, run these tests in this package, for example, or run this method. And then the engines and the whole thing do the rest. So this is what it looks like just with JUnit 5 in the game. You have all the tools down here. You have the platform runner here, It interacts with this JUnit platform engine, which is an API module or jar. It contains nothing, or few things besides some interfaces. At the top, you have your tests, which are implemented against the JUnit Jupyter API, which is a small artifact, also mostly annotations. And then you have the Jupyter engine in between. It implements this engine interface, and it operates on the JUnit API. On the Jupyter API. So to summarize, you have a clear separation of concerns in the API for developers and tools, but how is this next generation testing? This is the thing. This is the reason why the talk is not just JUnit 5 is nice for JUnit users, but why I think it's a huge difference, because it opens up the platform. So if you want to say you want to have JUnit 4 tests to run within this architecture, all you need is create an engine, which you shouldn't do because there is one, but the concept. If you want TestNG to have the exact same support like JUnit, you only would need an engine. Whatever else you can come up with, you only need to implement an engine. And as soon as you do that, as soon as you implement an engine, you can integrate it into this process. So the tools down here, again, they only use the same runner as before. You just plug whatever you use here, whatever, this is made up, right? So TestNG is not made up, but there's no integration to JUnit 5. So whatever you think you could write tests against, all you need is this artifact that implements this interface to make your testing framework of choice work within JUnit 5. And I think this is an awesome development, because once tools natively support JUnit 5, first of all, the tools themselves have most likely less maintenance effort into supporting different testing frameworks. They could theoretically say, we're not supporting JUnit 4 specifically anymore, we're just supporting the whole new JUnit 5 platform thingy. So they could drop support for other frameworks. But at the same time, these other frameworks would have most likely better support than today. As soon as they implement an engine, they get like 95% of the tool support that JUnit has now. And this means that developers can try out many more things, because now if you have an idea for a testing framework, it's kind of like it's a chicken-egg problem. Nobody's using a framework yet, of course, but it's hard to make them use it if there is no tool support, and to implement all the things you need for Maven and Gradle and various IDEs is a lot of work that you just, if you have a weekend project, you're not going to master. At the same time, on the other side, if you want to try out a new testing framework, you're in the same situation. It's hard to convince somebody in your team to use this new testing framework if there's zero tool support. And without using it, you will never ever be in the position to, or most likely not be in the position to give back to the project and support that project. So now you can. Now all the maintainer has to do is create an engine, a JUnit platform engine for his specific or her specific testing framework. And I think this could give rise to a new generation of test frameworks, which much easier to be creative, come up with new ideas, and at the same time try new things out and give good feedback and find out where the new approaches are valuable. So because the success of JUnit as a platform, that was once the thing that inhibited JUnit 4's development, because this becomes available to everybody, I think this could herald a new generation of testing on the JVM. There could really be, hopefully there will be many tools over the next years, new approaches to testing that you will be able to try out if you want to. JUnit 5, I think JUnit 5 is pretty nice, but it's still interesting to see what people can come up with. And they already do. There are a couple of different test engines already, which basically mostly they do this the spec thingy that also works. I think Kotlin does it as well. Where you can write tests in a specification kind of way. You can look up those links. And other projects already started. I want to name this one specifically because I began it, where people already start to interact with the extension model for Jupyter. So this would be a different engine, and this would be projects that mostly interact with Jupyter's extension model to provide new features for it. And the JUnit team has a list with projects somewhere that you can look at. So the real summary of the architecture is, as I said before, separation of concerns, but these are the important parts. It opens up the platform, and it might lead to tool support for basically every testing framework that people can come up with. And talking about architecture, there's even a little bit more to the story. Do you have questions about that? Are you now convinced that this is the next generation of testing? Is it production ready? JUnit 5 production ready? No, it's not. We can have a look at the setup slides in a minute. First of all, there was not even a general availability release, and as I said, we expect one in September. So let's say sometime in fall, and then full support in tools will likely take a moment longer. IntelliJ is really good at the moment already. You already get nice tips when you do something wrong with parameterized tests, for example. Will complain that there is no source, so they are definitely on the bleeding edge of this. Eclipse integration is lagging a little bit, but well, we just look at those slides then, right? This is for the tool. So IntelliJ, you can already use it since this version. If you want to use Milestone 4, you have to use this version though. With Eclipse, you get early access support if you install some milestone of the upcoming 4.7 release and then do some shenanigans. It's linked in this issue. I didn't find anything for NetBeans. And Maven and Gradle, there's support developed by the JUnit team. So as a proof of concept and to get people started, they implemented a Maven Surefire provider and a Gradle plugin that does the basics. And they handed them over to the teams. So the Maven team got the source code and will most likely use that to start on a Surefire integration. And apparently Gradle wants to revamp their test, how they approach testing, how testing works within Gradle. So that might take a while longer. But you can already use the plugins that are there. And you can see the user guide for how that works. Let me go to the beginning of this just to say one last thing, one important detail. So if you want to use tests, you just do this. If you want to write tests, you just need this one artifact. This is you now recognize everything you need to know. You'll see the Jupyter here because it's just the Jupyter API you want to use. And just this one jar. As I said, support is still work in progress, but IntelliJ already works quite well. Build tools, I also just told you how to use in the build tools. If none of this works, if you want to if you're stuck on an old version of IntelliJ maybe or NetBeans or something, what always works is kind of like backwards. So we've just seen how JUnit 4 could be run as part of JUnit 5. You can do the same thing the other way around. This here is a class which will contain JUnit 5 tests, but you use this JUnit 4 annotation. So, and then you use a tool which runs JUnit 4 tests. It will see this as a JUnit 4 test class, instantiate this runner, and then tell it to run this thing. And this runner knows how to run JUnit 5 tests. And if you don't want to do that for every class, you can do it like this. You can have one class that you just put anywhere in your code, in your test tree. It doesn't matter where. And then just say select a couple of packages. And then with this selects all packages that are below that as well, right? So it interprets them as hierarchical. So this way you can have one test class and have all of them run as part of JUnit 4. So if nothing of the other steps work for you, this does. There's a console launcher. I'm not going to go into that. You can run from the console. It has nice, colorful output. It's pretty good. It's the most up-to-date launcher at all times because it's developed by the same team. So you can start writing tests right away. Only IntelliJ has native support so far. Other IDEs are catching up, and there's provisional Maven and Gradle support. That is working fine. It works fine for demo projects. I'm sure if you have a big project, you might have specific needs that they don't fulfill yet. But I hope that by the end of the year, support will be much better than that. And if you run with JUnit 4, it's a good compromise. If you have older tools, that works. Final summary slide. You've seen the new API, which is like an incremental evolution of what you know before. You've seen dynamic tests, which I didn't show you why, but which can be pretty useful. But you mainly focus on parameterized tests, which show a nice way to create tests for different parameters. Look at the extension model, which I think is very promising. And the main thing why I like JUnit so much is the architecture, which really opens up the platform and gives other testing frameworks the chance to integrate with it. And tool support is not quite there yet. That was that. Thank you. Usually I plug my book, but with the recent decision for JSR 376, I would hold off on buying. Who knows whether it should at some point be called the Java 10 module system? I don't know. And we'll find out, I guess. If you want to know more about that, I recently wrote a newsletter. I have a pinned tweet you can find here where I talk about the module system of the upcoming thing. Otherwise, you find me on my blog here, and I write a newsletter here, and Google Plus, and blah, blah, blah. If you have any questions, you can ask them now, or if you see me run around the conference or in the city, whenever. So, more questions? Yes? Test coverage, the question about test coverage statistics. I think the team tried to use Jacoco on their own code base and didn't work out that well. So I'm not sure whether that's already a working thing or just a thing that needs to work at some point. Okay, if there are no more questions now, I'm gonna let you go. Oh yeah, one more. Can you mix JUnit 4 and JUnit 5 tests in one project? Yeah, you've seen the slide, remember, where you had the three things side by side? So you can use that mechanism to do that. So yeah, that's not a problem. Actually, that would be my recommended approach. There's no reason to move JUnit 4 tests to JUnit 5. That would be a lot of effort for no real benefit. I recommend you can start writing JUnit 5 tests like right now, and maybe sometimes you have to use an extension, a runner or rule, which you don't have a JUnit 5 variant of that yet, then even write new tests in JUnit 4, it doesn't matter. You can basically mix and match them in the same code base. And with this architecture of two different runners, each runner will only execute the test that he's in charge of. Yes?
My question is, why it's not production ready? I mean, he's going to skip some tests? Or?
Why is it not production ready? Well, it works fine. But first of all, tool support is not quite there yet. And then second of all, there could be breaking changes. They are unlikely, but it has not been officially released. So breaking changes would mean rewriting tests, and nobody wants to do that. I'm out of time. Thank you very much. Goodbye.